Welcome to lecture number 20, section 3.12. Alright, so now we're finally looking at the other way to solve systems of linear equations. Alright, so we're going to look at solving them by two different methods. One is called elimination and the other one we call substitution. So previously we were looking at how to solve a system graphically, and we saw that it works, but it would not work as easily if you had answers that were either possibly fractions or decimals. It worked better for nice whole number answers. But when you're working on actual application problems, whole number answers are not always what you'll end up with. So let's look at the substitution method first. For solving a substitution method, what you're first going to do is solve one equation equal to a variable of your choice. So most of the time we have generically x or y. So you'll pick one of these variables and solve the equation for it. After that, you take that new equation and substitute it into the other equation that you have not touched. Then you'll solve your equation for the variable, and when you find your answer, you're going to resubstitute that back in to the first equation and find the answer of the other variable. Because remember, we're solving for two different variables, which is normally how you get the answer x comma y. Because you're looking for a point. Because recall, graphically, these are two lines intersecting somewhere. Now we're just looking at how to solve it without having to graph. We can just work with the equations. So let's go ahead and work on using the substitution method. Well, when I look at my two equations, first thing that I do notice is that the top equation is already solved for a variable. It's solved for y. So that takes out the first step for me. So what I'm going to do, we're going to plug the first equation into the second one. Now how are we going to do that? Well, notice this equation is saying that y is the same as 3x plus 7. So if I was to write the second equation down, notice in the second equation we also have the variable y, which we know happens to equal 3x plus 7. So that's what I'm going to do. I'm going to replace y, I'm going to substitute it with 3x plus 7. Hence the name substitution method. Alright, so replacing it with that, I get 2x minus 5, and we replaced the y with 3x plus 7. We have substituted in this value, because that we know that's what y equals. Right, equal 4. Okay, so we've done the first step. Now we're going to go ahead and do step 3, which is to solve for our variable. If you want to pause the video and go ahead and solve, you could totally do that. Alright, let's go ahead and get rid of that parenthesis. We have 2x minus 15x minus 35 equals 4. Let's go ahead and combine those two x terms. Negative 13x minus 35 equals 4. Alright, let's get x by itself, so add 35 to both sides. And we have negative 13x equals 39. Alright, let's bring this up to the top. Ooh, that's really hideous. Okay, bring it up to the top. And lastly, let's go ahead and divide by negative 13. Ooh, that was ugly. And divide by negative 13. And we get our answer is x equals 3. Negative 3, actually. Alright, so we're not actually going to box our answer. You might say, why? Well, because remember, we're solving a system. We need x and y. So we need that little coordinate set. Right now we just have x. So we can box our answer, but this is not our final answer. We need to go back and find y. So how are we going to do that? Well, recall that we know y equals 3 times whatever x is plus 7. We have that right there. So we'll go ahead and substitute in the value of 3 for x. Then we get y equals 3 times negative 3, which was the x value, plus 7. Y equals negative 9 plus 7. So y equals negative 2. And remember, we need to answer for the system, which is negative 3, comma, negative 2. that is the answer for our system, and this is where our two lines intersect at that point. Alright, so if you want to pause the video and go ahead and try this example by yourself, you can go ahead and do that. So, the first thing that we know is we need to sub one into the other. They're both actually perfectly set up to be subbed into one of the other equations. So it's kind of up to us to decide which one we want to sub in. I'll just go ahead and sub the first one into the second one. Why not? Okay, so I know that y equals this large amount here, and I'm going to go ahead and substitute that into the other one. So let me go ahead and set up the second equation. Y equals negative 800x plus 16,000. And we're going to substitute this value for y, which is right there. Boop. Alright, so I'm going to have to squish my equation over a little bit. I didn't really leave myself room. So then I have negative 500x plus 13,000 is equal to, bringing this value over here, negative 800x plus 16,000. Alright, let's go ahead and solve. So getting the x values on one side, I'll go ahead and add the 800s to both sides. And in the same step, I'll go ahead and subtract the 13,000 from both sides. So negative 500 and 800 is going to be 300x equal to, and 16,000 minus 13,000 is going to be 3,000. Alright, let's go ahead and divide by 300. Let's see, those zeros cancel and we're left with 30 divided by 3. Which simplifies into 10. And remember, we're not done. We need to solve for y. Very good, yes. Gotta solve for y. So recall that we know y equals negative 500x, oh, it looks like an 800. Negative, oops, let's back that up, wrong pen. Negative 500x plus 13,000. Alright, so to find y, we're going to go ahead and sub the x value in for y. Just plop that in right there. Okay, so subbing in that x value so we can solve for y. So then we get y equals negative 500 times the x value of 10 plus 13,000. So then y equals negative 5,000 plus 13,000. So then y equals 8,000. So the answer, remember the answer to this system is going to actually be your x value first and then your y value. Because once again, we are looking for where your lines intersect. Because remember, these are both equations of lines. Alright, moving on. The next type of way that we can solve, and please note, if on the exam you're asked to solve for one way, you need to solve in that method. If it says the method is up to you, the method is indeed up to you. So the next method is called elimination, also known as the addition method. So I think in the book it uses the words addition method, but normally I call it the elimination method. Alright, so the plan. First, you want to make sure both equations are in the form ax plus by equals c. Then you're going to try and match the equations so that one of the variables is the same. And we'll go over this in a sec. After that, you add or subtract the two equations together to try and cancel out one of the variables so that you have one equation in one variable. And then you solve and go and do the same thing we did previously. Alright, so let's take a look at this. Well, so the plan is, I want them in x, y, number form, which both of these are. We have the x value, the y value, and the number. X value, y value, and number. So they're already set up perfectly. So now what I want is to match one of the variables. And what do I mean by match? Well, to match, they should either both look like 2y, or maybe negative 4x, negative 4x, something like that. So if I take a look at the x values right now, they're different. I have a 3x and a 2x. So I could try and match those, or I can actually take a look and notice that the y's are the same. So I'm going to go with the y's. All right, our plan is to get rid of the y's. So plan, eliminate the y's. Hence the name, elimination. All right, and to do that, we're going to either add or subtract the two equations together. Now, when I add or subtract, I want to cancel the equations. So, asking you, if I was to add y to y, would that cancel them? No, I just end up with 2y. So I know I'm not going to add. I'm going to subtract. So let me go ahead and rewrite my equation. And let's go ahead and subtract. So it's going to be 3x minus 2x. So that is going to end up being 1x. 2, then we have y minus y. And they cancel, which was our plan. Remember, if they didn't cancel, something went wrong. And then we have 6 minus 8, which is going to be negative 2. Let me move that x over. X equals negative 2. So now we have to figure out how to find y. Well, same thing, we're going to plug x value into either the top one or the bottom one. It doesn't matter which one. So let's just use the top one. Normally use the simpler equation. And let's sub negative 2 in for the x value. And solve. So 3 times negative 2 plus y equals 6. Negative 6 plus y equals 6. Let's add 6 to both sides to get y by itself. And we're left with y equals 12. And remember, our final answer is always going to be in the point form, if possible, which is negative 2, 12. And remember, you could end up with the answer of no solution. But right now, we've just been ending up with the answer of an actual point, which is great. All right, let's move on. So, looking at these equations, they're not in the xy form. So that's the first thing I'm going to have to do, is get them into the xy form, which means I want to subtract this 3x to the other side. So I can do that. So then I rewrite it as negative 3x plus y equals 7. All right, so I just fixed that equation there. I'll do that on the side just in case that was too much of a jump there. So to get it in the perfect form of xy and then number, there we go. All right, so we did that. The other one, it's already in the perfect form, so we can just write that one down. Okay, so now the plan is I want to match one of the variables. Now looking at the two variables, are any of them actually matched right now? Well, the x's, there's a negative 3 and a 2, so the x's aren't matched. And then for the y's, there's a negative 5 and a 1, so the y's aren't matched. All right, now we're going to have to pull out the trick of multiplying the equations by a number to match the variables. So plan, we need to match the variables. And I'm thinking here, if I wanted to focus on the x's and make them look the same, what could I multiply them by to make them the same number? Well, the closest I could get to is making them both look like 6's. So I can multiply the 3 by a 2 and the 2 by a 3. And then I would get negative 6x and positive 6x. So we could work with that because they're both 6's. if I wanted to focus on the y's, though, what would I do for the y's? You can pause the video and try to see what you would do for the y's. So for the y's, I have positive y and negative 5y. Well, I could just go ahead and multiply this one by 5, and then I would get 5y and 5y. That would also work. But you know what? I think what I'm going to do is go ahead and work with the one that has the most steps, just so you can see all the steps worked out. So I'll go ahead and match the x's. So my goal, match x's. To do that, I'm going to multiply the top one by 2. So both sides of the equation. Remember, you have to multiply both sides of the equation. This is a common mistake students do, so please make sure to watch out for that. And then I'm going to multiply the bottom one by 3. Alright, so the byproduct of changing the values is all the numbers have to be multiplied by the same thing. So the top equation, we have the 2 multiplied out to these ones. So then I get negative 6x plus 2y equals 14. And then the bottom one, I get, distributing that 3 out, 6x minus 15y equals 12. Alright, and now the x's are basically matched up. So the plan here, now I'm going to decide to add or subtract these equations together. If I were to subtract them like we did before, that would be negative 6x minus 6x, which would actually be negative 12. So the subtraction, that's not going to work. Which means, let's go for addition. So now we're going to add the equations together. Remember, our goal is to cancel the x's. So 6x minus 6x, negative 6x plus 6x is going to be 0. And then 2y minus 15y is going to be negative 13y equals 14 plus 12 is going to be 26. Alright, so let's divide both sides by negative 12. Negative 13. And we get that y equals negative 2. Alright, so we've solved for y. Awesome. Now what we need to do is solve for x. Well, we can use either of these equations to solve for x. Either one would work. I like to go for the simplest equations if possible. So I'm going to go ahead and use the top one. It looks like it has the smallest numbers. And let's substitute in the y value of 2 to solve for x. So negative 2 equals 3x plus 7. Let's add 7 to both sides, or subtract, sorry, from both sides. And then we get negative 9 equals 3x. Ooh, it's going to divide perfectly. Divide both sides by 3, and we get negative 3 equals x. So, how do we do our final answer? In the ordered pair form, yes. And there we do. So, now you know 3 different ways to solve a system of linear equations. There's the graphing, substitution, and elimination. And unless you're told a specific way to use, you can use either method. Alright, so let's take a look at the last example for this section. So these are applications of systems of equations. So normally, with our word problems, we normally would only have one variable, one thing that we don't know about in the problem. But now, since we're looking at applications for systems of equations, there are actually going to be 2 things that we do not know in the problem, which means that we'll need to use 2 variables to solve. And for some reason why are you crooked? It's not wanting to cooperate with me right now, so we're going to have to go with a slightly crooked screen. Okay. So we have two unknowns, and we're first going to want to identify those two unknowns in our problem, and those are going to be our variables. That's the first step. Second step, write a let statement for them, because we always need to do that when solving a system. Solving an application. After that, we're going to determine the two different types of units in the problem. Why is this important? Well, because we need to make two equations. So, in order to do that, we're going to have to set up two different types of equations. Now, not always. This won't always happen, but most of the time you'll have two different units. What do I mean? For example, you might have dollars, that'll be talked about in the story, and then the next thing, it'll be talking about so dollars, and then we might have number of tickets. You might have these two subjects in the story, and this, you use dollars to make one equation, and number of tickets to make the other equation. So that's what you want to look for. You want to look for the two different types of things you're talking about in the problem. Then you'll create one equation, and then a next equation, and after that, you're going to solve the system. Let's take a look at example 3. Kim sells bubble tea at the farmer's market. A small sells for $4 and a large for $6. She made $320 last Saturday when she sold 58 drinks. Set up a system of equations to determine how many of each drink size she sold. Be sure to state what each variable represents. Set up an equation, and solve and answer in a complete sentence. Alright, first thing we got to figure out, what are we trying to find? Let's see. To determine how many of each drink size she sold. So these are the unknowns. We want to know how many small she sold and how many larges she sold. Those are the two variables, the two things we don't know. So let x equal number of smalls. And let's just use x and y, generic. Let's y equal number of larges. Okay, so that's our variables. Now let's go ahead and determine what different types of units. Well, let's see. I see dollar signs going on here. I have $4 and $6, and then I know that was a total of $320. Any other units we see? Well, we saw that she sold 58 drinks. That's the number of drinks. So those are the two different types of units we have. We have dollars, and we have number of drinks. Okay, so let's go ahead and try set up two equations. One in term of dollars, and the other in term of number of drinks. Let's go with the number of drinks first. So we know that the number of smalls, let me back up on the color here. Let's stick with the red. So we know that the number of small drinks and the number of large drinks is 58. We know this. Well, I could write this as an equation. What is the number of small drinks? That is x. And then what is the number of large drinks? That's y. Okay, so let me go ahead and first back up. Okay, good. So x, and this is y. And in math is just the plus sign. Is equals, and then 58. So, right here we have our first equation. X plus y is 58. That's the total number she sold. Okay. Let's go ahead and box that equation. Now we need to determine our other equation. And we said this one is in terms of dollars. So let's see. Well, I know we have $4 for small and $6 for large. So each small she sells, she makes $4, right? So if she sold one small, she would make $4. If she sold two smalls, she would make $8, right? If she sold three smalls, she would make, well, that's just going to be 3 times 4, right? That's going to be $12. So basically, it's the number of drinks she sells times 4 for the smalls. And then for the large, we're going to use the same concept. However many larges she sells times how much they cost. So if I sold 2 larges, I would just multiply that by 6 and I would get $12. Alright, sounds good. So let me go ahead and erase this. We have that concept set up there. So I know it's going to be x times 4 is the smalls, plus y times 6. And how much money did she make in total? She made $320 total. Alright. Alright, so there we go. We have our 2 equations. So let me go ahead and set this up a little nicer. And we have x plus y equals 58, and 4x plus 6y equals 320. Alright. Since I'm running out of room on this page, I'm just going to go ahead and erase my scratch work above and rewrite my equation up a little higher so that I have space to solve. You can go ahead and just use an extra paper if you want. Okay, so we can choose 2 options for solving. Well, actually, we could technically have 3. We could try graphing, but that tends to be unreliable, so I'm not going to choose graphing. I could do substitution or elimination. Since I already have my x, y, and numbers lined up, I'll go ahead and use elimination. That means I got to match one of my variables. So I'm going to go ahead and try match the x. I want to make them look like 4x, which means I'm going to multiply this equation by 4. And I'll get 4x plus 4y equals 232. So if you want to pause the video and try to continue solving this by yourself and then check back in with me, go ahead. Alright, so to cancel out the x's, if I chose addition, that would be 8x, so that didn't cancel my x's. So I'm going to go ahead and choose subtraction. So 4 minus 4x is gone. 4y minus 6y, that's going to be negative 2y equals, then 232 minus 320 is going to be negative 88. Alright, we have almost solved for y. Let's divide by negative 2, divide by negative 2. So we'll get y equals 44. We're not done. Remember, we got to solve for x. So let's go ahead and solve for x. We can use either one of the equations. I'm going to go ahead and use the top equation. Why? Well, it has smaller numbers. So it's just easier to use the one with smaller numbers. Now what I'm going to do is substitute in the y value of 44 for y in this equation. Oops, wrong pen. X plus, we're substituting in 44 equals 58. So x plus 44 equals 58. Let's go ahead and subtract 44 from both sides. And we get x equals 14. But remember, we're not going to answer in a coordinate point set. Why not? Well, because this is a word problem. We have to answer in a sentence. So what did our variable stand for again? Well, if you remember, x was the number of small drinks we sold, and y was the number of largest we sold. So my answer is going to be, let's see, who is this? She. Kim. Kim sold, let's see, 14 small drinks and 44 large drinks. Period. And there we go.